All right, so to simplify expressions like this, we just pretend that I, which is really the imaginary unit, remember it's equal to the square root of -1. We treat it like it's a variable x, and we write our final answers in a plus bi form. So instead of putting the variable first like we're used to, we actually put it, bless you, we put it last. Okay, so our goal here is to simplify inside each of the parentheses, but there's nothing to simplify on each side of either of these parentheses. There's nothing to do. So now we work on getting rid of them. There's nothing to distribute on the first one other than a 1, so we can just drop them. And then here we distribute the -1, we get -3 minus 5i. So once you expand it all out, now you can combine like terms. So we'll do the numbers first. 2 minus 3 is -1. 1i minus 5i is -4i. And that's it. That's your answer. -1 minus 4i. That's your complex number. The real part is -1. The imaginary part is -4i. Pretty straightforward. I would probably take off 1 point because we want to get in the habit of writing our answer in a plus bi format. It is equivalent, but we want to make sure we write it as the real part first, and then plus the imaginary part. So put the I term last. Get in that habit. Okay. Any other questions on A? All right. On B, same thing. We distribute the negative. We distribute the 2i, and here we get -5 minus 2i, and on the next one we get plus 6i minus 2i squared. Okay. Now we pretend like these are x's. If these were x's, we would combine these like terms. We would say it's -5 plus 4i, and then we'd say minus 2i squared. The only thing that's different now is we have to remember that I squared is the imaginary unit squared. It's not just x squared. And what is I squared? Yeah, we got to remember that I squared is -1. I squared is -1. So whenever you have an I squared, you want to substitute it with the -1. Put parentheses where the I squared used to be and substitute a -1 in there. And now that we have a -1 there, we keep going. Okay? We multiply those together, we get -5 plus 4i, and that becomes +2. And then I can combine these numbers to get -3 plus 4i. So we distribute, combine like terms, replace I squared with -1, and then we just keep going. Keep going. Is 4i minus 3 correct? You lose a point, okay? You want to make sure it's written in a plus bi format. The real part is -3, and the imaginary part is 4i. All right, what's I squared equal to? -1, yeah. Like, tattoo that on the back of your eyelids right there so you can see it every time you look out. I squared is -1. Okay, multiplying complex numbers. We'll call this the next example. If these were x's, what would you do to expand this? What algorithm would you use, or mnemonic device? FOIL, right? You would FOIL it out. You're going to do the same thing here. You're going to FOIL. First is 2 times 2, that's 4. Outer is 2 times 5i, that's 10i. The inner is going to be minus 10i. And then the outer is going to be -25i squared. So that's your first step. Now we combine like terms. What's 10i minus 10i? Those cancel to give you 0, and we're left with -25 times I squared. So what am I going to do when I see an I squared? Yeah, I'm going to put parentheses first, and then I'm going to come back and put, well, with a highlighter, I'm going to put a -1 in there. I squared is a -1. And then I resimplify. I get 4 plus 25, which turns into 29. Okay, these two factors right here are very, very important in regards to each other. One of them's plus, and one of them's minus, and that's the only difference between them. Do you remember what we call those? When one of them's plus and one of them's minus? We saw it in 1.1. It rhymes with conjugate. Those are conjugates. Yeah, good. These are conjugates of each other. One of them's plus and one of them's minus. Just interesting to note that when you multiply two conjugates together, your middle terms will always cancel out by design. Middle terms cancel. It's pretty cool. All right, let's try this monster or this behemoth, right? Inch by inch, it's a cinch. I got 1, 2, I got 3 terms, 3 term groups. In each of those term groups, I'm going to distribute, okay? Let's do it one at a time. If I multiply the 4i in, I get -24i and then I get plus 8i squared. Don't replace I squared with negative 1 on this line. Leave it visible as I squared right here. We'll replace I squared on the next line. But you do want to make a mental note that we do have an I squared. All right, in the next one, we're going to have to FOIL. So we get 2 times 3 is plus 6. The outer is going to be plus 4i. The inner is going to be minus 3i. And then the outer is minus 2i squared. So again, don't replace I squared right there. Just make a mental note that we picked up another I squared. And then the last, we distribute the negative 3. And we get negative 15 plus 24i. All right, now we're going to do two things on this next line. We're going to combine like terms. Let's start with any numbers. Do we have any numbers? I have a 6 and a minus 15. So that gives me a what? Negative 9. So I double underline them. I guess I could have single underlined them. Let's do the I terms next. I have a negative 24 plus 4. That's negative 20. And negative 20 minus 3 is negative 23. And then I have a negative 23 plus a 24i. What's 24 minus 23? 1i. So I get 1i. Cyclops, if you will. 1i. And then I combine my I squareds. I'll triple underline them. I got 8 of them minus 2 of them. What's 8 minus 2? 6 of them. Now that you've combined all your like terms, on the next line, that's where we replace I squared with negative 1. Okay? We replace I squared with negative 1 once we've combined like terms. And now that just becomes minus 9 minus 6. So that's minus 15 plus I. Inch by inch, it's a cinch, right? Inch by inch, it's a cinch. Not hard, a little bit tedious. You got to be detail-oriented, sorry, and you got to be organized. But don't forget, I squared is negative 1. Don't forget. Use that as a whole separate step if you need to. Number goes first, right? Is I minus 15 acceptable? No, you'll lose a point. It's number plus the I term. So the real part is negative 15. The imaginary part is I. All right, it says, notice that it simplifies to a real number or no I's are left. Oh, that's the complex conjugate. Yeah, we already talked about that. All right. So let's talk about the conjugate. We call them a complex conjugate because they're complex numbers. A plus bi and a minus bi are complex conjugates of each other. What changes between them? The I term. One of the I terms is plus, one of the I terms is minus. The real part stays the same. A plus bi and a minus bi. Now, if you notice, like up here, whenever we expand two complex conjugates together, we end up with a single number. There's no i's left. It ends up being just a single number. Okay? That's pretty cool. So here's what we're doing on this example. Write the complex conjugate of each number and verify the product is a real number. So let's just go ahead and write it side by side. 3 plus 5i is the first complex number. And then next to it, in parentheses, what would be the complex conjugate? 3 plus 5i, yeah. So we'll write it side by side. Now, if we FOIL this out and we simplify it, it should give us a real number. Let's try it. 3 plus 3, or 3 times 3 is 9. That's your first. Your outer is plus 15i. Your inner is minus 15i. By design, those will cancel. And then you're left with minus 25i squared. So don't replace I squared with negative 1 on that line. Leave I squared visible there. But make a mental note, okay? Now we can combine like terms. Well, your 15 i's will cancel because they are opposites of each other. And we're left with 9 minus 25 times I squared, which is now really negative 1. That negative 1 will turn the 25 to a positive number, and we end up with 9 plus 25, which is 34. And there's the answer. Whenever you multiply two complex conjugates together, you end up with a number, a real number. All right, 6i. What would be the complex conjugate of 6i? Negative 6i, very good. Because 6i is really 0 plus 6i. And the complex conjugate will be 0 minus 6i, or just negative 6i. This one's easy, right? There's no foiling to do. We just multiply like parts. What's 6 times negative 6? Negative 36. What's I times I? I squared. And now in the next line, we'll replace I squared with negative 1. We do that as a separate line. And now we multiply a negative times a negative, and we get in a highlighter, no thank you, positive. Positive 36. All right, I'm going to let you do C by yourself, but I want to get you set up first. If negative 3i plus 4 is a complex number, what would its conjugate be? Would it be negative 3 minus 4? No. What do we need to do first? What's wrong with this? Based upon Lauren's question earlier. Right, we need to rewrite it 4 minus 3i. We don't want to write it in that form. We want it to be in a plus bi form. Now, what would the complex conjugate be? 4 plus 3i. Okay, y'all go ahead and do that one by yourself. I'm going to do it silently up here, and we'll compare our answers. Gobble it up. Make sure as you're writing straight down, every line is equivalent to the line above and below it. Every line should be equivalent to the line above and below it. I actually skipped a step. I was comfortable skipping a step. If you ever skip a step, you got to be careful because you could trip and fall while you're trying to skip, right? Fall flat on your face. You make a careless mistake and you get the wrong answer. I think the answer is 25. Did y'all get 25 as well? Yeah, I only skipped that one step of replacing I squared with negative 1, which would have normally come right in here. It would have been 16 minus 9 times negative 1. Okay, but I did that in my head carefully, not carelessly. All right, so far so good? All right, complex fractions. Complex fractions. Let me show you how to handle complex fractions. To handle a complex fraction, you're going to well, let me just walk you through it. You have 3 plus I, 8i, all over 2i. There's a couple of ways you could go about handling this one. I'm trying to think of the way that I want to show you. We have to get the I out of the bottom, okay? That's our goal. We want to get the I out of the bottom. Because this is an expression, we have to multiply by something that doesn't change its value. What do we multiply anything by without changing its value? 1, okay? Because what's anything times 1? No, itself. Itself. Anything times 1 is itself. Now, I'm not going to multiply by just any old form of 1, like 1. I'm going to multiply by a clever form of 1. And you know what that clever form of 1 is going to be? It's going to be the conjugate of the denominator all over the conjugate of the denominator. So conjugate over conjugate. It should be the same thing, right? So as we already saw, if the denominator is 2i, what is the complex conjugate of positive 2i? Negative 2i, right? Negative 2i. So multiply by negative 2i in the bottom and negative 2i in the top. What is that really equal to? 1. Is that okay to multiply by 1? Yes, it's got to be in the top and the bottom. Javier, earbuds out, please. Thank you. All right, now let's go ahead and multiply in the bottom. As we just saw, when you multiply two complex conjugates together, you get out a real number. So negative 2i times positive 2i is negative 4i squared. I'm going to show that step. I'm not going to call I squared negative 1 right there. In the top, I have two terms, so I actually have to distribute from the right-hand side, which is legal. If I distribute from the right-hand side, I get negative 6i minus 16i squared. All right, so far so good? Now, it looks like I made it messier, didn't I? It looks like I made a big old whopping mess of things, but look what I created. I created two opportunities to get rid of some i's. So let's now show the separate step. Inch by inch, it's a cinch, right? Let's just replace I squared with negative 1 in the top, and we'll replace I squared with negative 1 in the bottom. I'm going to take a whole separate line just to do that. Inch by inch, it's a cinch. Baby steps. All right, now in the top, I get negative 6i. I don't know why I always insist on writing with a highlighter. I hate myself. Negative 6i. And then negative 16 times negative 1 is positive 16. Positive 16. All over negative 4 times negative 1 is positive 4. Okay, my goal was to get the I out of the denominator. Did that do the trick? Yes, okay. Now, to get it into A plus BI format, I have to do a couple of things. First of all, is the numerator written in the right format? No, so I'm going to flip that around. I'm going to call it 16 minus 6i all over 4. That at least gets the denominator in the right form. Now, here's the trick. I got to split it up, okay? I got to split it up. So it's going to be this over that minus this over that. So it's going to be 16 over 4 minus 6i over 4. Are you okay with that? It's the opposite of adding fractions. When you add fractions, you need a common denominator. So when you split up fractions, every term gets the entire denominator, okay? 16 over 4 minus 6i over 4. And now I can simplify. What is 16 divided by 4? 4. And then 6/4 doesn't divide out perfectly, but it does simplify to what? They have a common factor of 2. So 3 over 2. And the I in the top can go off to the side as a coefficient, if you will. So we get 4 minus 3 halves I. Now what does that mean? That means that our original expression, 3 plus 8i over 2i, is exactly the same as 4 minus 1.5i. They mean the exact same thing. But 4 minus 3 halves I is written in A plus BI format. A is 4 and B is negative 3 halves. Okay? It all started with multiplying by a clever form of 1, which was the what? Conjugate of the denominator over the conjugate of the denominator. You got it? Okay, I hope so, because you're doing B on your own. Go. Multiply by the conjugate of which one? Does it matter which one? The conjugate of the top or the conjugate of the bottom? Does it matter? Conjugate of the bottom. Yeah, because the bottom is what we're trying to get rid of the I. So you multiply by the conjugate of the bottom over the conjugate of the bottom, and you FOIL it out. You expand it out. The conjugate. How do we get the conjugate? Is it the same as the bottom? The conjugate does what with the middle sign? Changes it. Changes it. So the conjugate of 5 minus I, the conjugate of 5 minus I is 5 plus I. We changed the sign of the imaginary part. So you should be multiplying, at least at this step, by 5 plus I over 5 plus I. Everyone should be at that step now. 5 plus I over 5 plus I. And then you just got two sets of foiling to do. You FOIL the top, you FOIL the bottom. You're going to end up with a couple of I squareds. On the line after that, you call them negative 1. You simplify, and then you split up the fraction if you need to. I'm going to catch up with y'all. The conjugate of the bottom. If I don't have to flip it around, it's already in standard form, A plus BI. So it's 5 plus I, 5 plus I. Now, when I multiply it out, I make one big denominator. Let's go ahead and do the denominator first, because by design, that should give me a constant, a real number, shouldn't it? Let's see, I get 25 on the outside. I get plus 5i on the inside, minus 5i, sorry, on the inside, and minus I squared on the last. So that's how you FOIL it, first, outer, inner, last. In the top, the first is 5, the outer is plus I, the inner is negative 10I, and the last is negative 2I squared. That one's going to be a little bit wacky because they're not conjugates of each other. Okay? So that should be your first step. Foiling the top, foiling the bottom, or I guess your second step after the conjugate over the conjugate. Now we combine like terms. I'll start in the top. I've got a 5 that's hanging around. I've got I minus 10I, that's negative 9I. And then I've got a negative 2 times I squared. Well, guess what I'm calling I squared? Negative 1. And I'm taking a whole separate line to do that. In the bottom, the 5 i's cancel by design. That is by design. And we get 25 minus I squared. And again, I'm putting parentheses where I squared used to be. And I'm putting a negative 1. Baby steps, right? Inch by inch. All right, now in the top, I get 5 minus 9I plus 2. And in the bottom, I get 25 plus 1. And now I combine like terms. 5 plus 2, I get 7 minus 9I, all over 26. And now the gross part. I got rid of the I from the bottom, didn't I? That was my goal. Now the last thing I do is I split it up. They're not going to be pretty numbers. I get, without a highlighter, oh my gosh, 7 over 26 minus 9 over 26 times I. And that, as gross as it is, that's A plus BI format. A is 726, that's the real part. Negative 9 over 26 is B, and then times I is your imaginary part. Yucky, yucky, gross, gross. But fun, right? It all started with the conjugate over the conjugate. So, conjugate of the denominator over conjugate of the denominator. Foil it all out. Replace I squared with negative 1. Keep going, simplify. And then the last thing is you split it up. Okay? All right, that takes care of this lesson. The time that we have left is yours to work on your homework for 5.1, okay? 5.1 homework. Tomorrow we're going to quiz. 5.1. Yes, 5.1 is due on Thursday a.m. at 9 a.m., okay? And then Thursday, which is tomorrow, we're going to quiz 1.1 and 5.1, okay? And then Friday is dance day. Yeah, come to school dressed as your favorite dance, and we'll just dance all day, all class free. Okay? I like the hot potato, hot potato, hot potato, hot potato. You ever remember the Wiggles? Hot potato, 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 potato. Mashed banana, mashed banana. Y'all didn't grow up with the Wiggles? No? Oh, yeah, the lawnmower or the sprinkler. Yeah. There we go. That's Friday. And then if we get tired of dancing, we'll start 5.2. Sound like a plan? Dance day and 5.2. All right, any questions?